Thank you for watching my videos. So we're gonna go ahead and continue on with this lesson. So this is the end of 5.1. So we'll be finishing with it this week. So we're gonna go ahead and start with example 6. Before we start with example 6, I did write on your unit circle, there is coordinates. If you notice, they're called terminal points, but they are coordinates. So they're like x comma y, but if it helps you, I wrote this. It's known as x and y, and inside you have that sine is y and cosine is x, and tangent is y over x. But I wrote it easier so you can see it. Cosine is first, which is x, and sine is second, which is y. So the reason why we focus on that is because we're going to be finding terminal points and reference points. So we're combining everything that we learned into example 6, and that's going to be part of your homework, the rest of your homework that I told you about yesterday. So if you look here, there is positive and negative right here in the corners. So on the corners there, they talk about positive numbers and negative numbers. Basically what you're focusing on is the sine and the cosine. So what is positive? What is negative? Here it tells you in the first quadrant, sine, cosine is positive. Negative, there's none. Second quadrant, positive is sine and cosine is negative. Third one, sine and cosine is negative. Fourth one, so that means your x and y is negative. Your fourth one here says sine is negative, cosine is positive. So you have to be very careful with the quadrants. I like this paper because it shows you everything that you need. It's right there. So now, let's go ahead and get started. Example 6. Terminal point, or the number we have here, is 5 radians over 6. According to my steps, I start with finding the terminal point. To find the terminal point, let's go ahead and translate this or convert this to degrees. So 5 times 180 divided by 6, I get 150. So now I get 150. 150 will be right here. I'm finding the reference number. To find the reference number, remember again, it's the other side. So it's this part right here. So 150 is about there. So I'm going to find my reference number. So it's that T with the line above. That means I'm going to subtract by either 180 or 360. That's your only two options. So I'm going to subtract by 180 minus 150, and I end up with 30. So my terminal point is 30 degrees. The second point is to find the terminal of your reference number. If you look at that, we're not looking at 150. Oh, excuse me. We're not looking at 150. We're looking at what we just found, which is the reference number. So we're looking at the coordinates for 30. So the terminal point is basically your coordinates, so x comma y. So if I look at 30 in my chart, 30 has the coordinates here, and it says radical 3 over 2 and 1/2. Those are the coordinates I am going to be writing down. Radical 3 over 2 and 1/2. But we're not done there. We're not just using these coordinates, we're also following by the quadrants. So there are 4 quadrants. The first quadrant, the second, the third, and the fourth. So remember what I said about the positive and negative. If we look here for 30 degrees in the second quadrant, that's where this is. This is in the second quadrant, right here. If I look at the second quadrant, if I read what it says sine is positive and cosine is negative. So if you leave the answer because I found what 30 is, and you leave it like this because they're both positive, that's wrong. Remember, the reference numbers is always between 90. So your options are 30, 60, 30, 45, and 60. So I look at this, I have 30 degrees. It's in the second quadrant, my reference number. So then my cosine is negative, but my sine is positive. So your final answer is negative radical 3 over 2 and 1/2. And that would be your answer for the first one. Next one. We'll go ahead and convert this to degrees. So I'm not going to do the work. But if I convert this, I get 315 degrees. 315 degrees is about right here. So I go around right here. I'm trying to find this angle here. So to find the terminal point, I am subtracting 360 because now it's closer to the 360 than the 180. So 360 minus 180. And that is 45. So it's my 45 degrees. If I look at the chart for 45 degrees, my terminal point is right here. Terminal point is radical 2 over 2. Sorry, that's a 2. Comma radical 2 over 2. So finding the reference point, finding the terminal of that point, and then looking for the positive or negative. So here, this is the fourth quadrant. According to the fourth quadrant, cosine is positive, so that's the first one. But the sine is negative. So that's for B. C, negative 2 radians over 3. To convert this, we get negative 120. So negative 120, if we were to draw that out here, that would be about right there. Sine angle is just there. So now we have to go ahead and find our reference number. So we're still trying to find this point here. Again, from yesterday's lesson, remember all our reference numbers are between 0 and 90, and they are positive. So here, negative 120. Another point for negative 120 is 240. So if I look at this, it's also in contact with 240. They are the same line. So therefore, you can find out by also adding 360 into it. So plus 360. And you end up with another angle, which is 240. So now we have to find the reference angle. Go ahead and subtract 240 minus 180. And you end up with, I believe, is 60. Find your reference angle. Now find the terminal points. You're finding the coordinates. 60 degrees, the coordinates are 1/2 radical 3 over 2. Right there. It's that point right there. Now, third step, we're in the third quadrant. According to the third quadrant, everything is negative. So therefore, this is negative and this is negative. That's it for example 6. Now let's go ahead and look at example 7. So again, everything is in radians. So it looks like it's 29 radians over 6. Obviously, it's not in this chart right here. So there is a trick to go ahead and simplify it. Example 7 says finding the terminal point for large t's. So that means for larger numbers. So it's not in here. If you were to convert this, it would be like 4,000 something. It would be a huge number. But in this case, we're not going to try to convert it to degrees. We're just going to keep it in radians, in terms of radians. If I just look at this as a fraction, 29 over 6, I can change that into a mixed number. If I change this into a mixed number, it turns into 4 and 5, 6. The difference here is instead of just looking at it as a mixed number, 4 is now considered radians. So remember, every time you go around, it's considered 1 radian. So 1, 2, keep it going, 3, 4, 5, 6, 7, 8. It's in terms of radians now. It's not the number 4 anymore. So for this case here, we are going around 4 radians. So a whole circle, 360, is 2 radians. So that means we went around the circle twice. And now we're left with 5 radians over 6 in the very end. So the trick to it, make it into a mixed number, and don't forget to add your radians into it. But radians, again, it's not just any normal number. It's different from the degrees, it's different from your calculator. You have to understand the concept is how many times you're going around that circle. If you have any questions, go ahead and email me. Thank you.